Welcome to EDU World Space.
Problem 8.57. So this is using the same setup as example 8.14 in section 8.5 of the book. So we have these two guys, Ramon and James, on a frozen lake playing tug of war over to get to a cup of some sort of beverage. They have these masses and so forth. The rope is light enough that we don't need to worry about its mass. And for this problem, we're asked to suppose that Ramon pulls on the rope to give himself a speed of 1.1 meters per second. And now we want to figure out how fast that's going to cause James to go. So, because everybody's starting off at rest here, the net momentum is 0, and the velocity of the center of mass, therefore, is 0. And further, since there are no external forces able to act on Ramon and James and the rope, the momentum has to be conserved, and so the velocity of the center of mass stays the same. And so knowing that the velocity of the center of mass is going to be 0, we could set this up quite conveniently. Like everything with center of mass, it's just a weighted average. So it'll be James's mass times his speed plus Ramon's mass times his speed, although I just said those in the reverse order in which I wrote them. But multiplication is commutative, so let's not spend too much time worrying about that. And then to actually take the averagey part of the weighted average, you have to divide by the sum of the weights. In this case, they're actually masses, but they're called weights just in general. So we know that this is 0. And to do the algebra here, we see, first of all, that we can multiply both sides by the sum of the masses, and because this is 0, it doesn't affect it. So mj vj equals negative mr vr. And now look, this looks suspiciously like a conservation of momentum problem, because it is just a different way of going about thinking about it, which is more convenient in some cases. In some cases, it doesn't really make a whole lot of difference. In some cases, doing the way we've already seen a bunch of times with just directly writing out the conservation momentum might be the easiest. All these things there's many options for how to do most problems, and part of the real learning in physics is learning to sort of spot what's the easiest way going to be to go about doing it. So the speed of James is going to be the negative of the ratio of their masses times the speed that Ramon set himself off going at. And so if we say that this is the positive x direction, it doesn't really matter. And in fact, this is already the positive x direction. So let's say that this is negative. We only really want the speed, so the actual direction, as a matter of sign convention, is not super important here. Well, let's say v sub r here is negative. So that gives us that James's speed is going to be positive 0.47 meters per second.